Nick Floeck and Milton Yu, who will be telling us about ASM connectors for automating instrument data capture and analytics. And I think Milton's starting.
Well, first of all, thanks everyone for coming back from lunch for us. So my name is Milton Yu. I'm the head of strategy for automation and analytics at Benchling. And today my colleague Nick Floeck will tell you about how Benchling is using Allotrope to help our customer to automate data capture and analytics. I know that many of you probably have heard of Benchling, I think. But three fun facts you may not know. So first of all, Benchling has been around for quite a while. We actually started in 2012, so over 10 years. We are now over 750 employees globally. I think we are one of, if not the biggest, standalone software provider for the biotech R&D space. And secondly, like many of our customers, some of you are sitting here, we are heavily invested in R&D. So over 40% of employees are in product development, design, engineering. This allows us to ship over 245 features in the past 12 months. Now, we don't invent features in a vacuum. We are a very customer-driven company, and we are very fortunate to work with over 1,200 customers, from small biotech startup to some of the largest pharma company in the world. And over 200,000 scientists use Benchling for their R&D work. The reason I tell you all this is because being around in the industry for a while, so I've seen many changes happen in the industry. And it started a few years ago. We started this annual report called State of Tech in Biopharma. And I think the latest one just got released today, so you can go to our website and take a look. And for this year, we interviewed anonymously over 300 experts in the industry, asking them how technology is helping them for their work. Now, you can imagine that we ask many questions. I'm sure every one of you has your own digital priority in terms of digital strategy. So you can imagine that when you ask many questions, most people have different bias of which one they really think is important. But when it comes to connecting instruments in the lab, the response is unanimous. Over 82% of respondents say that this is the most impactful thing for them in the next 12 and 24 months. But obviously, there are many challenges. And top two challenges people cite is that, first of all, there lack a standards of data and the interface for instrument output. And secondly, they just don't have the resource internally to code for the parsers to integrate those instrument data into their informatics system. So this is why Benchling really believes that our investment in Allotrope Foundation partnership will be the key to solving these problems. And we are very convinced because we already see this happen in other industry, be it telecommunication, finance, or consumer health information exchange. Standardizing data really helps to spur the growth for those industries. So we see how this will play out, and we hope we can all agree on this, is that there may be 3 steps here. The first step is that someone needs to define data standards for this instrument data. And I think everyone sitting here and Allotrope Foundation is taking a lead to help the industry lead us through this in the past 10 years. And the second step is that the users of the instrument need to invest in the adoption of these data standards. And thirdly, and I know there are many, some of the largest instrument makers represented here in the room here, but I hope we can all agree, at some point, ideally, the instrument makers themselves will just make the data standard default for all their data output from the instrument. So in terms of our investment for the Allotrope, we invest in the first 2 steps. So first of all, we invest heavily to contribute and to create more ASM models. And to give you one example where this is very important for us. So we've been working with a couple of large pharma company in their journey of using AI/ML in their work. So for some of them, we work on, how can they use more AI/ML in their antibody discovery R&D. So for example, how does a wet lab scientist can use SOTA model in their work in silico to predict, and also how dry lab scientists can use more wet lab data for their model training. Now, if you take a step back, looking at the flow here for antibody discovery, now one thing will jump at you is that there are many assays. And each assay have many methods, and each method uses many different instruments. So for all this flow here, there are tens or hundreds of instruments involved. And to train a model to predict binding affinity, you need more than 50,000 data points. So there are all kinds of instruments involved here. So when customer asks us, how can we help them solve this? We think the first step is investing in creating a data standard for binding affinity analyzer. And this is why this is one of the first ASM model we actually invest in working with Allotrope to create. So over the last year and a half, we have been working with Allotrope to contribute or initiate 9 ASMs that we believe can help our customers to standardize their instrument data. Now, we are on our way to solving the first step, having data standards. What about adoption? Actually, I'm curious, raise of hand, does anyone here, your company, working on like codes or converters to parse instrument data into ASM at all? No? No one? Some people? Okay, I see more hands. Cool, it's great. We're in Allotrope conference, so I'm glad I see some hands raised here. But we think that it's really important that as users of instruments and of data, we can invest more in adoption. And this is why that at Benchling, we invest in building more, we call data converters, that will convert instrument data into ASM model. But more importantly, we are open source all these converters. So if you go to GitHub, you can see all the codes Benchling made to convert instrument data into ASM model. So why we do that? Because one thing we quickly realized that today, many companies are doing similar things. They are investing building parsers to parse essentially similar sets of instruments and to use them, integrate them into their informatics system. So why are we all doing this again and again on our own? Okay, the problem is not just because there's essentially a duplication of resource in the industry, but also that when you do it by yourself, it's very possible someone else already go down the path and can tell you a better way of doing things. So this is not just about the resource efficiency, but also doing things in a better way. So we believe that, seeing through other industry, if we can all open source these converters we're building and then pull together, not only this can help us all to save our resource, but also can help us build it better and accelerate ASM adoption. So for that reason, Benchling has been investing in building over 35 data parsers and open source all of them. And this data parser can support over 100 different data instrument models if the instrument model uses the same software system, uses the same data format. So we really are very excited to go on this journey, and we really want everyone else to join us to help us solve as a whole, as an industry, this ASM adoption and standardized data problem. And with that, I'll pass on next to tell you more with real examples how these ASM converters really can help our customer to automate data capture and analytics.
Thank you, Milton. It's cold enough in here for you guys. Wake up a bunch. Okay, so from a product perspective, in order to help our customers actually implement and drive adoption of Allotrope, our real goal is to help automate the analytics side of things using the data. And as an example, like you can imagine doing a quantitative ELISA, it's a pretty standard analysis that if you have multiple teams working across different labs, likely do the exact same way. So the ideal setup when you have multiple teams executing the standard analysis the same way many times is to make that consistent. So you have a structure that looks something like this, where lab 1, maybe they use Gen 5 software for their plate readers, and that analysis automation that you create works perfectly well for their scenario. But lab 2 uses Softmax Pro and Envision, different plate reader software with different analysis outputs and different raw data. They should be able to use that same analysis automation so you can drive consistency that ultimately leads to results that aren't just conformed and harmonized, but also from a processing perspective are consistent, so you know that it's quality data coming through. But the reality is labs are using different instrument brands today, and this is impacting analysis automation pretty significantly. In fact, most customers that we work with, their implementation of an analysis looks more like this, where it's bespoke. Each individual team for their particular instrument is building a one-off analysis. Maybe they're grabbing raw data, they're sticking it in Excel, running a VBA macro that does some basic cleansing. They're taking that output, they're dropping it in something like Prism to do a statistical test like an IC50 curve. They're then taking that, taking a screenshot, dumping it in PowerPoint, and then showing it to internal stakeholders. And then maybe they're taking that PowerPoint and putting it inside a notebook entry. And that's their definition of structured data capture, at least today, right? And this is common across many, many customers. We're all trying to move towards a world where we can automate and standardize both data capture and analysis, but it's a real challenge today, right? So effectively, that's what we're going to show you. We're going to do a live demo today, so keep your fingers crossed for us, where you'll learn how we're using Allotrope and the adoption of the ASM converters that Milton mentioned to help automate analysis for a quantitative ELISA, harmonize that across different types of instrument outputs so you can have one analysis that works interoperably across different types of instruments. And last but not least, also how that feeds into AIML automation, specifically for optimizing parameters, which you can use for strain engineering, strain featurization, bioprocess optimization, et cetera. All right, so moving over to the demo. So again, using quantitative ELISA as an example. Oh, you can't see that? I have to share a new screen. Let's see. How's that? All right, we did it. Okay, so if you're doing a quantitative ELISA, you're likely looking at an analysis that looks something like this, right? You have your samples mapped up, you've already calculated your standard curve, you've interpolated the results to come up with a prediction for your unknown samples, and then you're comparing those samples in something like a bar chart. Maybe you also have upper bound and lower bound limits for your quality control that you just want to visualize easily, right? But actually creating this analysis is that very bespoke process that I talked about, right? First, you have to get your raw data, you have to transform it to Allotrope or cleanse it so it's analysis ready. Next, you want to measure your samples in something like a heat map to compare replicates against your samples. You have to go through the process of calculating your standard curve, ultimately taking that standard curve with a linear or 4PL regression and interpolating it back onto your samples so you can come with a prediction for unknowns. And then finally, you're in a position to build a visualization that looks like this to get your answer, where you're comparing your samples for the experiment. So what's set up here inside Benchling is something called an analysis template. And basically, you could think of this as a pipeline where you can feed Allotrope data or raw data into it, and it runs a series of processing steps, aggregations, computed columns, statistics like linear and 4PL regression, interpolation, and creates all of those views, right? So what we're going to show you in this example is actually executing this for real. We have a sample file that came off a SpectrumX plate reader that will come in. It'll run through the conversion to Allotrope, run through the analysis template, and ultimately create results. So to do that inside Benchling, you hit retrieve data. So imagine you're a scientist executing this run. You select your latest file that was already synced automatically to Benchling. You hit process. And then behind the scenes, what's happening is the data is being converted to Allotrope. That analysis template that we showed you is running against the harmonized data. And let's see if we can catch this in the act here. Yep. So I just opened our analysis template that's kicked off and it's running now. And you can see it's feeding through the pipeline, creating all of our views, creating our calculated columns, running our statistical tests, and ultimately creating our final result. And not only that, but like one of the things that is very important about standardization of analysis is capturing the metadata context of how this relates to the incoming data from instruments and your experimental plan, which is already inside Benchling. So we're able to automatically ingest that back into the notebook and store it as structured analysis context to the experiment that you've related within your plans within Benchling. So that's step one. The second step, which we're not going to show you today, is to automate that same analysis using a different plate reader. And like Milton mentioned before, we have a number of different connectors across a variety of plate readers. Kaleido, Softmax Pro are other ones that we support. You can see the same kind of run is established like a Kaleido instrument output software, and the analysis template that we just showed you can run in a standardized way repeatedly to automate analysis and make that interoperable across teams. The same thing holds true for AI/ML. So data standardization is incredibly important in this space, especially when you're getting into things like bioprocessing. Full transparency, we don't actually have a Allotrope model in place for bioreactor standardization, but we know many customers that we work with are using Amber 250s. They're using a number of different bioreactors where they have to conform the data together to look at online, at-line, and offline data, correlate that, understand it, and make decisions about their recipe design. So what we're trying to do in Benchling is help automate that for customers and actually provide in silico recommendations to guide the design of experiments in a more efficient way. So to give you an example of that, this is an analysis template that ran with our AI/ML engine running in the background for parameter optimization. A normal thing that you look out in the bioprocessing world is something like incubation time as one of your parameters and how that impacts temperature and ultimately titer for something like concentration. You can see in just your regular analysis, if you were looking at the data in the left-hand side, you might see between incubation time of like 0 and 2 hours, you're seeing the highest titer in terms of concentration. But also, if you kind of squinted it, it looks pretty good around 8 hours, and there isn't much difference between that and like 12 to 16 hours. When you actually standardize your data and run it through an AI/ML algorithm, and you do tournament-style testing using to find the best fit model for the use case, what you can do is start looking at multi-variation in those parameters to find the most important ones that are impacting your ultimate titer, like temperature as an example. And more importantly, related to incubation time, if you come over here to the right, what the algorithm is doing behind the scenes is basically relating all the variability between parameters against each other. And you can see, instead of the 0 to 2 hour incubation time being the most impactful set of media to the to titer, it's really around 8 hours where, when connected to the other variability of your parameter space, you see the most enhanced amount of titer. So that's it. That's what we wanted to show you in terms of the demo today. Hopefully you all learned a little bit about, well, we have to go back to this slide too. Well, back up. All right. Hopefully you all learned a little bit about how Allotrope can really help to automate analytics and standardize your analysis across different plate readers that you're using across teams. That's predominantly our focus in helping our customers. I think one thing to keep in mind also, Milton kind of alluded to this earlier, is we're going to hear a lot in the next couple hours about other vendors, other companies that are using Allotrope and building these connectors, right? We do have this open source repo where we're enabling connectors to be developed and make it available to anybody. We actually have a deep dive on this a little bit later to show you how that works. There's some really great tooling in there to actually make Allotrope conversion easy too. And this isn't just for Benchling, it's open for the entire community, right? So I would just encourage you all, as you're starting to think about your own projects and taking instrument data and converting it to Allotrope, if you could consider this, we'd love to have you join us on just making this an industry effort so that we could really democratize adoption of Allotrope further.
I will even go one step further. If any of you are building converters, data parsers, talk to us and tell us why you don't want to contribute to Allotrope.
Thank you all.